AI can write essays, pass bar exams, and generate code. But ask it whether someone is being sarcastic, and the whole system falls apart. I tested every major language model on sarcasm detection, and the results are genuinely embarrassing. This video shows you exactly what happened. Sarcasm detection is not a niche problem. It sits at the center of sentiment analysis, content moderation, and customer feedback tools that millions of businesses depend on every day. When AI gets sarcasm wrong, the downstream effects compound fast. Before the results, let me explain the testing setup so you know this comparison is fair. I used a consistent dataset of 200 sentences pulled from 3 sources: Twitter posts, Amazon product reviews, and scripted everyday conversation. Each sentence was labeled either sarcastic or sincere by human annotators. Every model received the same prompt. It was simple and direct: classify this sentence as sarcastic or sincere and give a confidence score. No chain of thought prompting, no few-shot examples. I wanted to see baseline performance, the kind you get when a developer integrates the API and moves on. The dataset was balanced. Half sarcastic, half sincere. A model guessing randomly would score 50%. Anything below 60% is effectively useless. I expected most models to land somewhere between 70 and 85%. That expectation turned out to be wrong. Let us start with the results from the models that most people consider the gold standard right now. On sincerely positive sentences, accuracy was very high, above 90% across the board. The problem started the moment a sentence said something positive but meant the opposite. Take a sentence like this: "Oh great, another Monday." Every human who reads that knows it is sarcastic. 3 of the 5 models I tested classified it as positive sentiment and marked it sincere. 1 model called it ambiguous. Only 1 flagged it as sarcasm. And that ratio held across dozens of similar examples. The failure pattern was consistent. Models are trained on enormous amounts of text where positive words almost always signal positive meaning. When a sentence uses positive words sarcastically, the model leans on the surface signal and misses the actual meaning. It is a bias baked into the training data. Things got worse with deadpan sarcasm. A sentence like, "Wow, this product only broke on the 3rd day. I am so impressed." 2 models called that sincere. The phrase "I am so impressed" carried too much weight, and the model ignored the context of the product breaking. That is not a small error. That is a fundamental reading failure. Customer review sarcasm was the hardest category for every model. Reviews are written by real people with varied styles, and sarcasm in reviews is often dry and subtle. On this category alone, the average accuracy across all models dropped to 61%. That is just 11 points above random guessing. So why is sarcasm this hard? The honest answer is that sarcasm is a social act. It depends on tone of voice, shared history, and the gap between what is said and what is known to be true. Written text strips away tone. Language models have no access to what is true in the world in a grounded, reliable way. They only have patterns in text. There is also a cultural layer. Sarcasm looks very different across English dialects, let alone across languages. A British understatement reads as sincere to a model trained mostly on American internet text. A casual Australian sarcastic remark can look like genuine enthusiasm to a model that has not seen enough of that register. 1 model did perform noticeably better than the others. It scored 74% overall and hit 81% on the social media category. The difference was not the model size. The better performing model appeared to weight surrounding sentence context more heavily, picking up on contrast between consecutive sentences rather than analyzing each sentence alone. That finding points to a real design lesson. Sarcasm rarely lives in a single sentence. It lives in the gap between what was said before and what is said now. Models that analyze chunks of context rather than isolated sentences have a structural advantage on sarcasm, and that advantage showed clearly in the numbers. Here is what this means if you are building anything with AI sentiment analysis. Your model is probably wrong on sarcasm more often than your accuracy metrics show, because most evaluation sets underrepresent sarcastic examples. The number in your dashboard looks good because the easy cases dominate the average. Content moderation is another area where this matters. Sarcastic harassment is a known tactic. Someone can write something that reads as complimentary on the surface while being deeply harmful in context. If the moderation model cannot detect sarcasm, bad actors know exactly how to exploit that gap. There are a few partial solutions being explored right now. One approach uses multimodal signals, combining text with audio or video tone when available. Another approach uses retrieval-augmented methods to ground the model in real-world context before classifying. Neither approach is production-ready at scale, but both showed promise in the research papers I reviewed while building this test. Fine-tuning on sarcasm-specific datasets does help, but the datasets themselves are small and often narrow in scope. A model fine-tuned on Twitter sarcasm still struggles with review sarcasm. The problem generalizes poorly because sarcasm itself is context-dependent and domain-specific. The broader takeaway here is that benchmark scores on standard leaderboards do not tell you how a model handles the real, messy complexity of human communication. Sarcasm is just one example of a class of problems where surface-level language patterns are not enough. Irony, understatement, implication, and humor all live in the same blind spot. If you are evaluating a language model for any task that involves human-generated text from social media, reviews, or casual conversation, you need to test sarcasm specifically. Build a small sarcasm test set from your own domain. Do not rely on aggregate benchmarks to tell you something they were not designed to measure. The full breakdown of every model, every category, and every example sentence is in the video description. The methodology is there too, so you can run your own version of this test and compare your results. If this kind of honest, experiment-driven AI testing is useful to you, hit the like button and subscribe. Next week I am testing how well every major model handles ambiguous instructions, the kind that trip up AI agents in real workflows. That one has some surprises too. See you there.